Hello viewers, I am Kausalya. Today we are going to discuss about the problems related with KCL and KVL. So here the problem is a circuit consisting of three resistors 12 ohm, 18 ohm and 36 ohm respectively joined in parallel. Right, the three resistors are connected in parallel and that combination is connected in series with the fourth resistance. Three resistors in parallel and that combination of resistors are connected in series with another resistor. Right. The whole circuit is applied with 60 volt and it is found that the power dissipated in the 12 ohm resistor is 36 watts. Right. So power dissipated in the particular 12 ohm resistor is 36 watt. Determine the value of the fourth resistance and the total power dissipated in the circuit. Right. So the first step is we are going to draw the diagram. So here you see three resistors are connected in parallel and that combination is connected in series with the resistor R. Right, and the entire circuit is applied with a voltage of 60 volt. Right, so our diagram is like this. Now we are asked to calculate what is the value of R and the power dissipated in the circuit. Right. So first, from the given data, power dissipated in the 12 ohm resistor is nothing but 36 watts. Right, it is given in the problem. So what is the formula for power? It is given by P is equal to VI and I can be replaced by V by R. Right, so here it is V square by R. So what is the value of power? It is 36 watts. And what is the value of R? It is 12 ohm. So when you substitute the value here, we can calculate the value of V. Right, V square is 432 volt and V is 20.78. Right, so here you see, since we know the voltage here, that is voltage across 12 ohm resistor is 20.78 volt. You see, the voltage across this 12 ohm resistor, right, it is 20.78 volt. Right, so this same voltage will be impressed across your 18 ohm resistor as well as with the 36 ohm resistor. Say yes or no, because all these three resistors are connected in parallel. Therefore the voltage impressed across the resistors will be the same here. Right, we know the voltage, we know the resistance. So by using Ohm's law, we can calculate the current which flows through all these three resistors. Yes or no? Right, so now we are going to calculate the current flowing through this 12 ohm, this 18 ohm and this 36 ohm. So here the current flowing through this 12 ohm resistor, that is I12 is V by R. V is 20.78, the resistance is 12 ohm. So here we are getting the answer as 1.73 amps. Similarly, the current flowing through 18 ohm resistor is given by 20.78 by 18. So here the answer is 1.154 ohms. And the next one is I36, that is current flowing through 36 ohm resistor is given by 20.78 by 36. So it is equal to 0.577 amps. Right. And the next thing is, we know the voltage across this parallel combination as 20.78. Right. And the total supply voltage is 60 volt. Then what will be the voltage across this R ohm resistance? So here we have to subtract this 20.78 from 60. That is 60 minus 20.78 gives the value of 39.22 volt. Right. So you see, now we know the value of current flowing through these individual resistors. Right. So here it is 1.7316 amps and here it is 1.154 amps and here it is 0.577 amps. Right. Then what will be the current, that is the outcome current? So this current will be equal to summation of all these three currents, right? This is by again KCL. So this is a node. So sum of currents flowing towards the node is equal to sum of currents flowing away from the node. So here when you add all these three currents, we will get the value of I that flows through this resistor R. Right. Already we had calculated the voltage across this resistor. It is nothing but 39.22 volt. This is the voltage across this particular resistor. Right. We know the value of current now. We know the value of voltage. Thereby we can easily calculate the value of resistance by using Ohm's law. So this is what I had written here. You see the total current. That is, here we are having 3 resistors, and in series there is another resistor which is connected here, right? So the current, total current flowing, that is the outcome from these 3 resistors, the total current is nothing but summation of the current flowing in these 3 resistors, right? So just add the currents flowing through the resistors, and finally the value of current is 3.4626 amps, right? Now the current flowing through the resistor R is this one, and the voltage across that resistor is, we had calculated it as 39.22, right? You see here we have calculated the voltage as 39.22. So here when you substitute the values, the value of resistance is found to be 11.33 ohms here, right? And the next thing is they are asked to calculate the power dissipated in the circuit. So what is the formula for power? It is nothing but V into I, right? We know the value of V which is given in the problem, and we had calculated the current that flows through the circuit. What is the current that flows through the circuit here? Again, this is the current, right? This is our circuit. So this I is the current that flows through the circuit, right? So we had calculated the I also. So just substitute it here. That is VIV into I. So the value of power is 208 watts, right? Or in other words, that is, there is another method to calculate this. That is by using this formula. P is given by V square by R, right? So what is the value of R? Here we are having 4 resistors, correct? So we have to calculate the value of total resistance. How to calculate the total resistance? First we have to calculate the total resistance of this parallel resistors, and then we have to add it with this series resistor. Okay, this is how we will calculate the total resistance. So first we are reducing the resistors in parallel. So 1 by R is equal to 1 by 12 plus 1 by 18 plus 1 by 36, right? Once you take LCM, 72 is the LCM, so it occupies the denominator part. So just when you take LCM and calculate, finally the value of resistance is found out to be 6 ohms. Okay, this is the total resistance of parallel resistors. Now this has to be added with the resistor which is connected in series. So what is the value of resistor in series? We had calculated the value as 11.33 ohms. Right. So what is the value of total resistance? Here it is 17.33. Right. So what is the formula for power? It is nothing but V square by R. We know the value of V which is given directly in the problem. We know the value of resistance. Okay, just now we had calculated. So just substitute it here, and finally the value of power is found out to be 208 watts. Right. This problem gets over here. We will proceed with the next problem. So this problem is, find the value of R if the power dissipated in the 10 ohm resistor is 40 watts for the circuit shown, right? So this is the given circuit diagram, right? We have to calculate the value of R, and the only given data is the power dissipated in the 10 ohm is 40 watts, right? So power dissipated is given by 40 watts, and power is given by V into I, and I is replaced by V by R. Therefore it is V square by R here. So P is equal to V square by R. We know the value of power, we know the value of R. Therefore we can calculate, you see, we know the value of P, we know the value of R. So just substitute it here and we can calculate the value of voltage. So the value of voltage is, it is 20 volts here. Right. Now you see, this is the given problem, right? Now we have calculated the voltage across 10 ohm resistor as 20 volt, right? So here there is a total of 50 volt and 20 volt is across 10 ohm. Then how many voltage will be across this parallel combination? It will be 30 volt, right? That is 50 minus 20, 30 volt here. So again this 30 volt is impressed across this 30 ohm resistor, this 40 ohm resistor as well as this R ohm resistor. So we can easily calculate the value of current by using Ohm's law, right? So this is your V and this is your R. So the value of current flowing through 30 ohm resistor is 1 amps and the value of current flowing through 40 ohm resistor is 0.75 amps, and again the current flowing through this 10 ohm resistor, right? So we know V, we know R. So 20 by 10, that gives 2 amps here, right? Am I making things clear? We know the value of voltage, we know the value of resistance, so we are calculating the current. That's it, right? So here it is 2 amps and here 1, here 0.75. We don't know the current that flows through this R because the value of R is unknown, right? So you see, here the total current is 2 and this current gets divided among these 3 resistors, right? Or again by KCL. Current flowing towards the junction is equal to the sum of currents flowing away from the junction, right? So here it is 2. So here 1, here 0.75. So 1.75 goes through these 2 resistors. So 2 minus 1.75 gives you 0.25 amps, right? This is what I had written here. 2 minus 1.75 gives you 0.25 amps. So we know the value of current flowing through the resistor, we know the voltage. So again by Ohm's law we can calculate the value of resistance, right? So V is equal to IR, again R is equal to V by I. V is 30 volt and I is 0.25 amps. Therefore the value of resistance is 120 ohms here, right? This problem gets over here. So our next problem. The current in a 6 ohm resistor of the network shown in figure is 2 amps, right? The current flowing through this 6 ohm resistor is 2 amps. Determine the currents in all the other resistors and the voltage V across the network. So here we have to calculate the current that flows through all the other resistors, right? Totally here we are having how many resistors? 5 resistors. So we need to calculate the current flowing through the remaining these 4 resistors. And voltage V, we need to calculate the voltage also, right? So the only known data is current flowing through the 6 ohm resistor is 2 amps. So now can you make a guess how to proceed? The one and only thing is we can calculate the voltage across this resistor. Say yes or no. We know the current, we know the resistance, right? So it is I into R. Therefore 6 into 2, that gives you 12 volt, right? So here the voltage across the 6 ohm resistor is 12 volt, right? Again these 2 resistors are in parallel, right? Therefore this 12 volt will be impressed across this 8 ohm resistor, right? We know the value of voltage, we know the value of resistance, therefore we can easily calculate the value of current that flows through this 8 ohm resistor. So the value of current is calculated by again V by R. So here the V is 12 volt and the resistance is 8 ohms, right? So this is what I had written here. So the current flowing through this 8 ohm resistor is 1.5 amps, right? So here it is 1.5 amps. Now we can easily calculate the output current, right? The current flowing through this part. So it is nothing but here comes 2 amps and here comes 1.5 amps. So what will be the current here? 2 plus 1.5. Therefore the current in this part is 3.5 amps here, right? Now yes, the thing is, you see, So here it is 3.5 amps. Here what will be the value of current then? Again it is 3.5 amps only. Why? Why we are saying it as 3.5 amps? You see, this is a closed path, right? Again, when you combine these two resistance together, they become a single resistor. You see, here it is 4 ohm. When you combine 6 ohm and 8 ohm, you will be having a single resistor. And again, when you combine this 8 ohm and 20 ohm, they became another single resistor, right? And this is your circuit. This how your circuit will look like. And here the same current I flows through all the resistors. Do you agree or not? So that's the reason. So the value of current that flows through this path is also will be equal to 3.5 amps, right? So we know the value of resistance, we know the value of current. So we can calculate the voltage drop across this 4 ohm resistor, right? So the voltage drop across this 4 ohm resistor is given by 3.5 into 4, which is nothing but 14 volts here, right? Then the next thing is we are proceeding with the 8 ohm and 20 ohm combination, right? So here the current is 3.5 amps, right? And here we are having the two resistors. Now we are going to calculate the current flowing through each resistors here. So the current flowing through this 8 ohm resistor, it is given by total current into, that is current division formula, right? Total current into, if you need I8, you need to take the opposite resistance. So total current into opposite resistance divided by, you have to add these two resistances, 20 plus 8. Okay, this is the basic formula, you see. Total current into opposite resistance divided by total resistance. So here the total current is 3.5 amps. We are calculating I8. Therefore, the opposite resistance is 20 ohm divided by 20 plus 8. And similarly, the current flowing through this 20 ohm resistor is given by, the total current is again 3.5, right? The opposite resistance is 8 ohm. 8 divided by 20 plus 8 again. So that gives a 1 amps, right? So again this 3.5 amps gets splitted up as 2.5 and 1 here. Again, when you look at the output, we will be having the same 3.5 amps here, right? So now we are going to calculate the voltage drop across the resistors. So voltage drop across 8 ohm is 2.5 into 8, that is 20. And again 20 ohm resistor is 1 into 20, that is 20 volt, right? Again, since they are parallelly connected, the voltage impressed across the resistors holds the same, right? So again the circuit is redrawn. You see the voltage drop across this 4 ohm is 14 volt, and this combination is 12 volt, and this combination is 20 volt. We are asked to calculate the value of voltage. So just we have to add these three voltages, and finally the value of the V is 46 volts, right? Am I making sense here? We are asked to calculate the voltage. So in order to calculate the voltage, we have calculated the current that flows through the resistors. Once the value of current is known, we have just calculated the voltage drop across the resistors, right? And finally, we are adding up the value of voltages across each resistors, that is each resistor and combination of resistors. That's it. So the final answer of V is 46 volts, right? So here comes the end of this video. If you have any doubt, let me know in the comment section. Thank you.